This is the PWM85 solar charge controller. It's designed to solar charge your batteries. It's based on the PWM5 solar charge controller by Julian Illet, but this one uses an Atmel AT-Tiny85 microcontroller. It's a simple PWM solar charge controller designed to charge lead acid and 4S Li-Fi Po4 battery banks up to 13.5 volts. But as you can see, there is an ISP header here at the top, so you can adjust the code and of course adjust the regulation voltage to something that suits you better. The solar input is good for 36 cell solar panels, typically sold as 12 volt solar panels, and it will accept up to 100 watt panels. I brought the PWM85 now out into a sunny but breezy garden, and I'm going to connect it up through this multimeter, which is set in current milliamps mode here. So we're going to see the consumption of the PWM85. So without further ado, let's connect it up to this lead acid battery, and it's consuming 4.8 milliamps in the boot up sequence when the LED is on. But now there's no solar connected. We can see that here, no solar connected to this solar charge controller. It's using 0.74 of a milliamp, 740 microamps. That's really low, and that's been achieved with some circuit changes, changing the regulator to a 3.3 volt regulator, which meant the charge pump had to be adapted for that. But yeah, also quite a bit of that has been done in code. So I got it down to about 1 milliamp with the circuit design, and then with some help from a gentleman called Mark, I've been able to get the code working so that it now consumes less than 1 milliamp in idle. So yeah, 740 microamps. I'm really pleased with that. So I'm going to use this 100 watt solar panel here to charge this battery through the PWM85. You can see, well, I've already tested this, it's sat at 13.2 volts, and once I connect the solar panel to the solar input of the PWM85, we can see the voltage goes up to 13.5 volts, and it's regulating there nicely at 13.5 volts. We can now see that the LED has appeared on the PWM85. That's showing that it is at regulation voltage, and that's because, well, there's now spare energy in the system. The MOSFET is actually disconnecting the solar panel from the battery frequently, changing its pulse width, and therefore there's spare energy in the system, so the LED indicates that. And actually, the brighter the LED, the lower the duty cycle on the MOSFET. So yeah, it gets brighter as there's more and more spare energy in the system, and yeah, it's regulating perfectly at 13.5 volts. So the PWM85 solar charge controller is suitable for up to 100 watts 36 cell panels, but they can be teamed up so that you can have one attached to each of your solar panels, but all of them connected to the same battery bank. The design files, the schematics and the code are all available on GitHub, but for a limited time only, they're also available now to buy completely built in my Tindy store. All the relevant links in the description below. Hopefully you've enjoyed this video. If you did, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching.